Here we go. It's a graph. We're going to look at it and talk about it and write stuff down. Use the graph above to identify the following. And behavior. First and foremost, I'm going to write this down. I don't even need to look at the graph because I know this is going to be part of the answer. It is every single time. The thing about polynomials is that they always go left forever and they always go right forever. So this is saying left and this is saying right. All right, x negative infinity, x positive infinity. And you just have to write what is happening. Is it going up or is it going down? And in this case, it looks like both of them are going up. Since both of them are going up, these will both go up to positive infinity. Your choices are negative infinity or positive infinity. Since both are going up, they're both positive. If this was pointing down, you'd put negative. And there you go. Domain. Polynomials go left forever and right forever. So the domain's always all real numbers. You can write either one of these things. I do not care. For the range, though, the range you do have to do lowest to highest. Always in that order. So the lowest is right here, and you need to find out how low it is. So I'm going to go over here, and I don't know, I guess negative 5.5 it looks like. It's negative 6 is down here. So I'm just going to say negative 5.5 is the lowest. Oops. 0.5, comma. And then the highest, as you can see, it's going up. So the lowest is negative 0.5. The highest is infinity. Infinity is always a parenthesis. This right here is a dot. It is an actual point, which means we have to put a square bracket there. Number of turning points. Those are the things right here. So you just count 1, 2, 3. It's turning. I don't know how to explain it. 1, 2, 3. The answer's 3. Least degree of polynomial, you can just count how many times it makes lines and stuff. 1, 2, 3, 4. So it's 4. 1, 2, 3, 4. You can always double check because even numbers always go the same direction. If these were going opposite directions, then, same direction. These would have to be in even numbers. If it's opposite directions, then it would be an odd number. So you can, I guess, quickly kind of double check that. Estimate local minimums. Local minimums will be here and there. So this looks to be like, I don't know, negative 1.5, negative 1.8. Sure. Negative 1.5, negative 1.8. This one's going to be 2, negative 5.5. So it's just the ordered pairs. For local maximums, it's just that one right there. So 0, 0. That one's a lot easier. Real zeros. Zeros are where it hits the x-axis. In this case, it hits right there, it hits right there, and it hits right there. So that's negative 2, 0, and 3. Those are the zeros. Increasing. It looked like it's increasing here and here. Those are the places it's going uphill. And when you do this, make sure that you're using the x values for where it is increasing and decreasing. Always x values. So it's increasing from here to here, and it's increasing from here forward. So increasing, this is negative 1.5, I believe we decided, to here, which is 0. Union, 2 to infinity. And increasing, decreasing is always parentheses, no matter what. So negative 1.5 to 0, and 2 to infinity is where it's increasing. Which means the other places is where it's decreasing. Negative infinity to negative 1.5. Union, this is x is 0, this is x is 2. So 0 to 2. Whee! Sorry, I get bored sometimes. So then it says to write a polynomial equation that has the same solutions as the graph and passes through the point marked on the graph. The point marked on the graph was 1, negative 2. I'll just write that down. That's useful later. Okay. The next thing you need to know is the zeros. The zeros, negative 2, 0, and 3. This is going to turn into a lot like the problem we did on the previous video, where if you have these zeros, you can write them as factors. Like negative 2 is an x plus 2, 3 is an x minus 3. 0 isn't as obvious to people. It's just x. Like if you tried to write x minus 0, well, x minus 0 is just x. And whenever it's just an x, put it first. So x plus 2, and x minus 3, like that. So that would be with those zeros. However, this does not go through that point right there. In order to guarantee it, you have to find a number to put in here that would make it. On the previous video, we talked about, in the very beginning, how it said, assume the coefficient is 1. In this case, it doesn't say that because the coefficient is not 1. You have to find out what it is. So for the moment, we just call it an a. So y equals a times the stuff that we just found has to be there. And then you can use the ordered pair. Because remember, an ordered pair is an x and a y by definition. So we are going to take 1 and plug it in for x, and take negative 2 and plug it in for y. So it would look like y is negative 2, a is a, and x is 1. So this would be 1. This would be 1 plus 2. This would be 1 minus 3. All of the x's become 1s, and the y becomes negative 2. And then you can solve for a. I'm just going to scooch on over here. Negative 2 equals, a times 1 is just a. 1 plus 2 is 3. 1 minus 3 is negative 2. So 3 times negative 2 is negative 6a. And if you divide, this simplifies. 2 over 6, is 1/3. So a is 1/3. Luckily, nowhere in here does it say it needs to be in standard form. It just says write a polynomial equation. Done. So we don't have to FOIL it out like we did before. I can just write y equals, a was 1/3, and then all of these factors that we had over here. So 1/3 x, x plus 2, x minus 3. And that can be the answer. It's going to have a 0 at 3 because of this factor. It's going to have a 0 at negative 2 because of that factor. It's going to have a 0 at 0 because of that x. And because we put the 1/3 there, it's going to be that if you put in 1, you get negative 2, and it'll go through the point. And that's it for the problem. I say that's it as if it was easy and short. That's the whole thing. Good to be done. Awesome. We still have a minute to do this, maybe? Sure, it's not terrible. Draw a general shape and state the end behavior. Odd, positive. Those are the only things that matter. When it comes to positive versus negative, that always just tells you the last side, the right side. So it's positive, it goes up at the end. If it's negative, it goes down at the end. If it's positive, it goes up at the end. If it's negative, it goes down at the end. That's always the case. So you can just think about that. For the whole odd versus even thing, any odd goes the opposite direction. So for all these ones that say odd, it's going to go the opposite direction. It's odd, so it's going to go the opposite direction. Even will go the same direction. So since this one's going up, so will the other. It says even, so it's the same. This one's going down, so this one always goes down. So once again, odd is opposite, even is the same direction, positive means it goes up, negative means it goes down. And that is always on the right side. So use the right side. You always do this first. If it's positive, the right side goes up. If it's negative, the right side goes down. And then you look over here. If it's odd, do the opposite. If it's even, do the same. I'm just going to go ahead and just talk about these. It's going to take way too long to write it down. Just remember, every single one of them, you're going to do this. Every single time, just copy, paste, copy, paste, copy, paste. Everything I did in green is going to be written in every single one of these boxes. All you have to do is say, hey, this arrow, it points down, negative infinity. Hey, this side, it points up, positive infinity. For this one, it would be positive infinity and then negative infinity. This one, they are both positive infinity. And in this one, they are both negative infinity, like so. And then you can put in the rest of this stuff here, which I'll do at the beginning of the next video. Okay, see you then.